Electrolytes are substances which dissociate into positively charged cations and negatively charged anions in a polar solvent. Although an aqueous solution of dissociated ions is electrically neutral, the cations and anions are conducive to an electric current. Acids are compounds which release a positive hydrogen ion as they dissociate in water. Acids which dissociate completely are strong acids, while those which don't completely dissociate are weak acids. Bases are compounds which release a negative hydroxide ion, a hydrogen bonded to an oxygen, as they dissociate in water.
It is important to understand and be able to accurately measure pH because life requires specific pH to thrive. We can only survive with a slightly basic blood of 7.4. Plants can't survive in acidic soil, and marine life is dependent on neutral water.
Acids can neutralize bases, forming a salt in water. Acidity is quantified by pH, a scale from 0 to 14, 14 being the most basic, 7 being neutral, and 0 being the most acidic. pH is usually measured by the color change of litmus paper, but it can also be measured with other pigments. Red cabbage and kale contain an anthocyanin pigment which turns red in an acidic solution and yellow in a basic solution. We will evaluate the effectiveness of traditional pH indicators such as litmus and phenolphthalein, as well as unconventional pigments in red cabbage and kale. Litmus test. The litmus solution is a good indicator for acids. When the litmus solution is poured onto acids, the color changes into a light red. On the other side of the scale, the litmus solution is not a good indicator because when poured into non-acidic solutions, there is no change in the color of the solutions.
Phenolphthalein. This is a good indicator for bases. When phenolphthalein is poured into base solutions, the solutions turn pink. But when poured into other non-basic solutions, the color becomes cloudy, which shows it is not a good indicator for neutral and acidic solutions.
The red cabbage is good at distinguishing between strong and weak acids and bases. As you can see, in the red cabbage indicator, the bases turn blue, green, and yellow. Sodium hydroxide turns yellow. The ammonia turns green. Lysol, whose main ingredient is a base, turns aqua, and sodium hydrochloride turns blue. Neutral, deionized water, and rubbing alcohol remain purple, and acidic aspirin and vinegar turn red.
Kale indicator. The kale indicator is a good indicator for bases. This is observed when kale is poured into basic solutions and solutions turn yellow. But when poured into non-basic solutions, the solutions do not change color, but rather become cloudy. What do you call a substance which dissociates completely in water and causes hydrogen ions to form? Which indicator produces a pink color in a basic solution?
This project tested 4 indicators, 2 of which are homemade indicators, the red cabbage and kale, and 2 of which are laboratory prepared indicators, litmus solution and phenolphthalein. From the results we gathered, we can observe that homemade indicators are just as efficient as the laboratory prepared indicators. Having these indicators can help us know the pH of substances around us. Knowing the pH of substances can prove to be important in our everyday lives. The food and drink we consume and the medication we take can be acidic, basic, or neutral. If we ingest or come in contact with substances that are not suitable with our body's pH, it could be detrimental to our health. For instance, water tests that indicate a pH much lower or much higher than 7 may indicate dangerous impurities. Pools with a pH outside of the 7.2 to 7.8 range may irritate skin or allow pathogens to fester. With these simple homemade indicators, we have an inexpensive means of testing the pH of substances around us and keeping ourselves safe.